Okay, let's look at this next level of complexity, decomposing p of x over q of x, where q of x has a non-repeated irreducible quadratic factor. So it means that it's a prime quadratic. So the partial fraction decomposition of p of x over q of x, I don't know what happened to my division there, such that q of x has a non-repeated irreducible quadratic factor and the degree of p of x is less than the degree of q of x is written as. So notice here we have this is supposed to be the non-reducible quadratic factor, and so it's prime, and you have a1x squared plus b1x plus c1. And here I have capital A1 just to distinguish from the denominator. Capital A1x plus b1. Now it could be that a1 was 0, but we give it the ability to be a linear factor if that's how it works out, plus an a2x squared plus b2x plus c2. We have an a2x plus b2 on top. So capital A and B there. And again, linear factor, where this is quadratic, so it's 1 degree less on top. So the decomposition may contain more rational expressions if there are linear factors. Each linear factor will have a different constant coefficient, constant numerator a, b, c, and so on. How to decompose rational expression where the factors of the denominator are distinct irreducible quadratic factors. Use the variables such as a, b, or c for the constant numerators over the linear factors, and linear expressions such as a1x plus b1, a2x plus b2, and so on for the numerators of each of the quadratic factors. So we list it out like that. Same thing as before. Then multiply both sides of the equation by the common denominator to eliminate fractions. Expand the right side and collect like terms. Set coefficients of like terms from the left side of the equation equal to those on the right side. Create a system of equations and solve for the numerators. So here we have 8x squared plus 12x minus 20 over x plus 3 times x squared plus x plus 2. So this quadratic here cannot be factored. Overall, if we were to expand this out, the denominator would be an x cubed, so a cubic. That's 1 degree less than the numerator. So we're on the right path here. So that means we have 8x squared plus 12x. Sloppy. Need to look what I'm writing, not look what I'm writing from. 12x minus 20 over our x plus 3 times x squared plus x plus 2 equals, then we'll do an a over the x plus 3 plus, now the next factor has the x squared plus x plus 2, so we'll do a bx plus c over that. So same thing as before, we want to clear out the fractions. So let me rewrite this. We have an x plus 3 times x squared plus x plus 2 times 8x squared plus 12x minus 20 over x plus 3 times x squared plus x plus 2 equals x plus 3 times x squared plus x plus 2 times a over x plus 3 plus bx plus c over x squared plus x plus 2 times x plus 3 times x squared plus x plus 2. So now we get our red pen out and we divide out what divides out. Kind of satisfying. And what we're left with on the left side is our 8x squared plus 12x. Let me scroll this up. Minus 20, that's a 20, equals, then we have a times x squared, so ax squared plus a times x plus 2a plus, I have a bx plus c times x plus 3, so bx squared plus 3bx, I'm just foiling it, plus cx plus 3c. So let's collect what we have. So let's look at our constant on the left. On the left we have a minus 20. On the right, our constant, we have this 2a plus 3c. Then for our x term, on the left I see a 12. On the right I see an a, I see a 3b, and I see a just a c, excuse me. And then for our x squared, on the left I see an 8, and on the right I see an a and a b, a plus b. Excuse me. So it looks like we're going to have to go about this thinking about solving down here. I'm going to solve for a and put it in the second equation. So if I know that 8 equals a plus b, a would be 8 minus b. I'm going to put this in place of the a there. So no, that's not going to get me where I want to go, is it? Let me go the other direction with this. Because in that first equation I have an a and a c. So I guess I have to solve for b here. So b equals 8 minus a. And I could take that and substitute it in place of b. So I have 12. I'm going to have to use a lot of space here, so I probably should be a little more conservative with my space. 12 equals a plus 3 times, instead of b, I'm going to do an 8 minus a plus c. So 12 equals a plus 24 minus 3a plus c. So I'll subtract the 24. So negative 12 equals a minus 3a is minus 2a plus c. Oh, look at that. That works out nicely. And then we have minus 20 equals positive 2a plus 3c. So if we add those straight down, we'd have minus 32 equals 4c. So we divide by 4, c would be 8. And then we can get our a back, find our a. So we had minus 20 equals 2a plus 3 times c. 3 times c is 3 times 8, so it's 24. So negative 20 equals, oh, is that supposed to be negative? I think it's supposed to be negative 8. So negative 20. So if I add 24 to both sides, see, a negative can really cost you a lot. 4 equals 2a divided by 2, a equals 2. And then our b is 8 minus a, so b would be 6. So what do we start with? 8x squared plus 12x minus 20 over x plus 3 times x squared plus x plus 2 equals, and here's the fun part, because we did all the work already. Our a was 2, where's our a? There it is. 2 over the x plus 3. Then our b is a 6 times then the x plus, and our c was negative 8, so I'm just going to say minus 8. Let's say minus 8 over x squared plus x plus 2. Okay, that was pretty cool.